Have you ever sat on a plane and wondered why it never just backs away from the gate on its own? Cars do it, trucks do it, even your bike can roll backwards. But a 100-ton commercial aircraft, it just sits there until a little truck comes and pushes it back. So why can't planes reverse themselves? Let's find out. First, the simple answer. Jet engines are built to push air backwards, which shoves plane forward. That's it. That's literally how thrust works. Forward is the only direction this design naturally wants to go. Think of it like blowing up a balloon and letting it go. The air pushes out one end, and the balloon shoots off in the other direction. Jet engines work the same way, just with way more power and way less squeezing. Now, here's where it gets interesting. Some aircraft actually can move backward using something called thrust reverse. You've probably felt this before. Right after landing, when the engine suddenly roars lower and you get pushed forward in your seat, that's reverse thrust kicking in to help slow the plane down on the runway. So if reverse thrust exists, why don't pilots just use it to back away from the gate? This is where engineering meets common sense. Reverse thrust on most commercial jets is designed only for landing, not for taxiing or parking. Here's why. When an aircraft reverses its engine while sitting still, like at a gate, the thrust doesn't just go backward and disappear. It blasts outward and can get sucked right back into the engine intake. This is called FOD, foreign object derbs. Loose stones, dust, ground equipment, even airport derbs can get ingested into the engine. That is an expensive and dangerous problem. There's also the jet blast itself. A reversing engine throws extremely high-speed air in multiple directions. At the airport gate, that's surrounded by fuel trucks, baggage carts, ground crew, and sometimes even the terminal building itself. That blast could injure people or damage equipment nearby. And then there is visibility. Pilots sitting in the cockpit, way at the front of the aircraft, simply cannot see what's behind them. There are no mirrors, no backup camera, like in your car. If something or someone is behind the plane, the pilot would have zero way of knowing until it's too late. So between engine damage risk, jet blast danger, and zero rear visibility, reversing under engine power at the gate is basically asking for an accident. This is where the pushback tug comes in. That little vehicle you've probably seen attached to the aircraft's nose wheel. It physically pushes the plane backward, safely and slowly, with ground crew watching every angle and communicating directly with the pilot through headsets. It's not a workaround. It's actually the smarter solution. The tug gives full control, full visibility, and zero risk of engine damage or jet blast injuries. Now, some smaller aircraft, particularly certain regional jets and props, do have a feature called power pack, where controlled reverse thrust is used briefly to ease away from the gate. But this is rare. Requires very specific gate layouts, and most airlines avoid it because of the same FOD and safety concerns we just covered. There's also a structural reason planes aren't built for backward movement. Landing gear, especially the nose gear steering systems, are engineered around forward motion. The hydraulics, the tires, the steering mechanisms, they are optimized for rolling forward and turning, not reversing under their own power. Backward movement adds necessary stress and wear to systems that were never designed for it. So when you put it all together, engines built for forward thrust, safety risks for a reverse blast, zero rear visibility, and landing gear engineered for forward motion, you start to see why the humble pushback tug remains the simplest and safest answer. It's a great example of something in aviation you will see again and again. Sometimes the smartest engineering solution isn't making the machine to do everything itself. It's designing a smart and simple system around it instead of doing that. Next time you will be sitting on a plane and you feel that gentle tug before the engines even start, you'll know exactly what's happening and why it's happening. If you found this interesting, please hit like, share, and subscribe, and let me know in the comments what aviation mysteries you want explained next. Thanks for watching. I'll see you in the next one. Bye bye.